how to draw ray diagrams by using concave mirror. In this video, I'm going to explain. See, ray diagrams for the concave mirror. So, take the concave mirror and you draw the, I explain how to draw this by using the compass and by using the scale. First, you draw that. And we have the 5 conditions. When you place an object beyond C, at C, and in between F and C, this is condition 1, condition 2, condition 3, and when you place an object at F, and when you place an object in between P and F. So these are the 5 conditions. So in these 5 conditions, when you place an object in front of the concave mirror, you will get the different types of images. Sometimes you may get real and sometimes you may get virtual. But by using the concave mirror, mostly we will get the real images. Only at one condition we'll get the virtual image. That when you place an object, just one example I'm explaining. When you place an object in between P and F, you apply the rules we have the rules for to draw the ray diagram. So when your ray is parallel to the principal axis, the reflected ray should pass through the focus, and when your ray is passing through the focus and the reflected ray is passing through the, here I must take the ray diagram from the object. So when your ray is, it is not possible to draw from focus, so I'll take the rule 3. When your ray is passing through the center of curvature and the reflected ray also is passing through the center of curvature only. Means these two rays are diverging only. They're not meeting. When you place an object in between P and F, so the reflected rays are deviating. So when they're deviating, you will not get image. So these deviated rays, when you observe and when you extend, they appear to be meet at one point. Where they are meeting, there you will get the image. And in the situation P and F, here you will get a virtual image. Virtual image always when the rays are diverging. Okay, so virtual image, and it is the enlarged image. See, when you place an object far from the mirror, you get a diminished image. But when the object is placed or nearer the mirror, you get the enlarged image. And here you observe, when you place an object in between P and F, here you are getting the virtual image and an enlarged image and invert image. This principle is used in the preparation of shaving mirrors, and the dentist and the ENT specialists, they're using the mirrors. So this condition is used in the preparation of the mirrors. Next, coming to derivation for mirror formula. So what is mirror formula? 1 by F is equals to 1 by V plus 1 by U. Here F for focal length, V for image distance, U for object distance. Here this from pole to this one is the object, from pole to the image where you are getting here, this is the image distance, and the focal length where you are getting the focal reflecting rays, that it is focal length. So like this you can find. Next, to solve this, by using this you have to solve the problems. At the time you have to follow the sign conventions. Whether F is positive, negative, V is positive, negative, like that you have to take the sign convention. While sign conventions for the parameters related to the mirror equations. So what are the sign conventions? Means for the concave mirror, not only for concave mirror or convex mirror, always you have to measure the distances from the pole. You have to always measure the distances from the pole. Suppose if I take a concave mirror, when an object is placed here, and if this is the incident ray, and it is passing through like this, then to find out the image distance, I should start finding the image from the pole to this object. Always whatever the distance you are measuring, you start from the pole. That is the first point. Next, always start from the pole. Next one, when you are measuring the distances towards the incident ray, you must take it as positive. For example, here I am going to take it as object to distance. So I should start from the pole. So pole to this object I should go. Okay, I should go like this. Then, but the incident ray direction is along this direction, means these two are in the opposite direction. So at that condition, you must take it as negative. You must take it as negative, and both are in the same direction. Both are in the same direction. You must take it as positive. That is rule 2. And rule 3. The image, the image distance or the object's height of the image or the object distance, when you are finding, if it is above the principal axis, you must take it as positive. If it is above the principal axis, you must take it as positive, and if it is below the principal axis, you must take it as negative. So these are the sign conventions while you are deriving this mirror related to the mirror equation. Next, the last one is magnification. What is magnification? You are comparing the height of the objects. You are comparing the height of the objects or the size of the images, not object. You are comparing the size of the image with the size of the object. That comparison will express in the form of magnification. Generally, magnification means we'll get an increased size of the image only. So what is the relation between magnification? What is the formula for the magnification? M is equals to minus V by U is equals to HI by I for image, O for object. Height of the image by height of the object. The last one is making of solar cookers. So how to prepare the solar cookers? For this, we have to take one sheet and you have to make it as a dish shape, and to that dish you have to take an acrylic sheet and cut into 8 or 12 pieces. You have to make it into the isosceles triangles, and the side of this what are the sides of isosceles triangles? Equal sides are there. That side must be equal to the radius of that dish. Like that you must take it, and to that dish you have to fix that mirrors, and when the light rays falls on the mirror, reflection takes place. So where you can if you find the reflecting point, or if you observe that reflecting point, at that place when you place a vessel, you can cook food. So by using that, we can prepare the solar cooker. And the last one is we have the problems that I will send through videos. So I completed lesson 1 completely. So listen carefully and read the lesson. Thank you.